Hello students, welcome to the next lecture on conventional manufacturing processes, and in this lecture we will understand the different alignment tests required for the milling machine. Now we have already known that why alignment tests are required, because during machining operation there are chances that all the parts is available in the machine that may vibrate during machining, and also there are chances of wear and tear on the components available. So for the efficient working of the machine, we need to do the alignment test on regular interval to check if the machine is working properly or not. So the first and foremost test required for the case of the milling machine, that is to check if the table surface is parallel to the arbor rising towards the overarm or not. That means we have already known all the parts of the milling, right? So I think now you have the clarity about all the milling machine parts and where their parts are available. So now here you can see that what we are doing is to check if the table surface is parallel to arbor or not first. That means we need to check the parallelism between what? Between table and arbor. So what we are doing is we are placing the dial gauge base onto the table, and we are giving the main needle part of the dial gauge to the arbor. We are attaching that needle part of the dial gauge to the arbor. Now then after, we know the basic working principle of the dial gauge. So when we are moving the dial gauge, if there is a flat surface, then there are no variation on the dial of that particular dial gauge. But if there are any surface roughness or the uneven surfaces, then in that cases that dial gauge indicator will move in a forward direction or in backward direction according to the shape available. So if there is a movement in the dial gauge, that means there are chances that that particular part is not parallel to the part we are checking. So here what we are doing is, after placing this dial gauge or arranging this dial gauge on table and setting it towards the arbor, we are moving this dial gauge using the table handle. We are moving this handle, we are rotating this handle, and due to the handle movement, what happens, it is moving in particular direction. Now due to the movement, what happens when it is moving in forward direction or maybe in this backward direction? So if there is a perfect parallelism between table and the arbor, then during that situation this dial gauge will not indicate any movement in its dial indicator. But if this, there might be a chances if this arbor is slightly at inclined position, during that condition what happens, there are chances that this particular tool may get deviated and it indicates the result. That means if it is moving in forward direction or in backward direction, so if there is any inclination during the contact, then what happens, this dial indicator shows certain readings, and from that readings we can understand that if the table surface is parallel to the arbor or not. So just you need to understand that how we are placing the dial gauge onto this machine. So we are attaching this dial gauge to the in between the table and the arbor, and we are just moving the dial gauge in forward and backward direction to check if there is any parallelism error or not. Similarly, the second test available, that is to check if the table surface is parallel to the longitudinal movement or not. So that means this, during the longitudinal movement of the table, if this table is traveling during entirely in the parallel direction or not, if it is maybe inclined at certain angle, or if it is moving in an angular direction or at certain angle, means if table needs to be moved in horizontal direction only, but due to the continuous working operation there are chances that this particular table may get slightly inclined. So what happens, if this table is moving at certain angle, means at certain inclination, there are chances that it may be moving in this angular direction also. So to check if this table is moving in particularly a horizontal or parallel direction only or not, to check that we are doing this particular alignment test. So for that what we are doing is, on the end of the support or at the table end support, we are placing the dial gauge, its base is placed over here, and we are facing the end of the dial indicator towards the table surface. So at the side of the surface we are indicating this dial gauge. Now what we are doing is we are moving the entire table by using the handle arrangement. So if it is completely parallel, then this dial gauge will not deviate from its original mean position. But if there is slightly a inclination, maybe in this direction or maybe in this direction, during that what happens, the tip of the dial gauge or the tip of the dial that gets pressed, and due to that pressing, the dial indicator available over there that shows the deviation or reading in that particular its dial. So here again, during the movement of the table, if dial indicator is showing any deviation from the mean position, then we can say that this table surface is not parallel to the longitudinal movement. But if it is not showing any deviation, then we can say that this table surface is parallel to its longitudinal movement, right? And these movement related details we will also discuss during our practical sessions. Now the third one is to check the transverse movement parallel with the spindle axis. Now we know that this is the spindle axis. So with the spindle axis we will check two movements. So first one is transverse movement. That means if first we will check along the longitudinal direction also and along the transverse direction also. So we are placing the dial indicator on the length of this arbor and we are moving. Now I hope now you have the clarity how we are placing the dial indicator. So the surface at which we want to check the parallelism, at that particular direction we are indicating the dial gauge. So during this movement, if this dial gauge shows any deviation, then there are chances that the component is not parallel. Similarly, at this section also, section also, let us see the top view of this arbor or the side view of this arbor. If we see from this direction, this is nothing but the cylindrical section, and over here also if we point the dial indicator and we move over its radius or diametral direction, if it shows any deviation or from this mean position, that means we can see that there is not exact transverse movement. But if the dial indicator do not show any deviation from its mean position, then we can say that there is a transverse movement parallelism with the spindle axis. So the movement checked from this direction is indicated as the transverse movement, and if it is exactly parallel, then this dial gauge will not show any deviation from its mean position. Now the next one is to check the T-slot is parallel with the longitudinal table movement or not. So here what is the important thing that you need to understand? We need to check the parallelism between T-slot and the table. So what we are doing, we know that the T-slots are available on the base of the machine. So we are attaching a particular clamp or a particular component on the T-slot. We are fixing that component into the T-slot. And now to check with the longitudinal movement, what we will do is we will fix the base of the dial indicator on the arbor, and from that we will attach the dial indicator portion with the component attached at the T-slot. So if we have attached the component at the T-slot, then from the arbor we are attaching these dial gauge with the section that we are measuring. So we are checking. So now what we will do is, now we will move, after attaching this dial indicator with the component fixed, we will move the table. Okay, we will first move the table in length direction. So as the table is moving in forward and backward direction, this component, this dial indicator is directly in contact with the workpiece that is attached. So if this dial indicator shows any deviation, then we can see that there is no exact parallelism between the given component. But if dial indicator do not show any deviation, then we can see that T-slots are in exactly parallel arrangement with the longitudinal movement of the table. So that is how we are checking the alignment test or alignment of the different component or the different parts of the machine by use of the dial indicator. So in almost any of the cases we are using this dial indicator to check the alignment of the parts with any other relative parts available. Now the next one is to check the cutter spindle axial slip and the eccentricity of the axial external diameter. That means On this spindle, now the spindle is fixed. We know that this spindle or the arbor, that is entirely fixed over here. On this spindle only we are fixing our component. So now to check if this spindle section is not eccentric. What is the meaning of eccentric? Eccentric means, suppose if this is the center of the spindle, now during rotation, if its center gets deviated to the downward section or maybe on the upward section, so if it is rotating not towards the exact center available, but it is rotating about the another shifted center, so that particular distance is indicated as the eccentricity. So we need to also check if the component is rotating about its axis or not, because if it is not rotating about its axial direction only, then there are chances of chatter generation also, and we are not getting the exact machining required for our component. So it will also deteriorate the surface of the component that we want to machine. So here similarly what we are doing, we are placing the two dial gauges, first one at the bottom position as shown over here, and another one on the diametral section as shown over here. Now this section is gets rotated by using the motor arrangement, and during this rotation, if it is rotating about its central axis only, then there are the chances that this dial indicator will not show any of the deviation. But if it is vibrating about its central axis, then what happens? If it is eccentric, then these dial indicators, maybe this dial indicator or maybe B or both, will show the deviation from its mean position. And we can see that this spindle portion is not exactly rotating about its central axis, and there are chances of eccentricity on the component. So if we machine the component on this spindle, or we attach the tool on this spindle and do the machining operation, then also there are chances that we do not get the exact shape and size required. So this test is also important to check if this spindle is eccentric from its central axis or not. So these are the basic alignment tests are required to check if the components or the parts available in the milling machine are performing with its exact required purpose or not. So this alignment test is required during certain interval, and this is most and foremost important part. And in most of the cases, we have seen that the alignment test is carried out using this dial gauge indicator. So I hope you got the clarity regarding the different alignment tests available, and there are wide varieties of tests are available, but few are indicated over here for your knowledge purpose point of view, that you can understand how the alignment tests are carried out to check the alignment or the parallelism or the movements of the parts respective to the other parts available. So looking forward to see you all in our next lecture. Up to then, thank you.